Alright, this worksheet is meant to help you have enough understanding about friction to do worksheet 5. So in class, we did letter A together. We have a 10 kilogram object on a flat surface, and we have these coefficients of friction. When it's moving, that's the coefficient of friction. Before it's moving, when it's being pushed or pulled, the coefficient of friction is a little higher. There's a little more friction. To calculate the friction forces, we use the Fun equations, either for the kinetic situation of movement or static. Here's using the Fun equation. There's 60 newtons of friction force using the coefficient of kinetic friction times the normal. In this case, the normal is equal to the weight, and that's equal to the mass of 10 kilograms times g of 10 newtons per kilogram, where 100 newtons is the weight, 100 newtons is the normal force. So it shows up there, and 0.6 times 100 newtons is 60 newtons. For a static friction case, static friction is always going to be less than or equal to the coefficient of static friction times the normal force, which means it's going to be less than or equal to 75 newtons. Once the force goes over that, then it'll start to move and kinetic friction will take place. So you do B and C, and for the 20 kilogram object with these coefficients, we get that for kinetic friction, that for static friction. And on the moon, we have a different gravitational field strength. It's not 10, it's 1.6 newtons per kilogram. So the normal force on a 10 kilogram object is 16 newtons. And so 16 newtons normal force with the different coefficients of friction gives us those frictions. Kinetic friction 0.8 newtons, static friction 1.6 newtons. Jumping to number 3, a 50 newton force is applied to a 20 kilogram crate. So that's the mass. Resting on a level floor, coefficient of kinetic friction is 0.15. A force diagram is right here. It's on level surface, so the weight down. The weight is going to be the mass 20 times 10 newtons per kilogram is 200. And that is going to be equal to the normal force, so normal force is 200. It says a 50 newton force is applied, and we know there's friction because it mentions friction. There's the force diagram. The acceleration is going to be equal to, well, if we have forces, we're going to use Newton's second law to get the forces, and we're not going to be able to get the net force unless we figure out friction. So let's do that first. Friction equals mu times normal force. Mu is 0.15. The normal force is 200 newtons. So that equals 30 newtons is the friction force. So now I can put in 30 newtons to the left there. So the net force is 50 newtons to the right plus 30 newtons to the left. It's a minus over the mass of 20 kilograms. So that's really 20 over 20 or 1. And that would be meters per second squared.